Hey everyone, welcome back to another video of mine, where today we're going to be solving Leetcode problem 20 titled Valid Parentheses. So before we actually dive into the problem statement, if you guys haven't noticed it, I'm actually using a different audio device to actually record this video, so feel free to just comment down below in this video of which one's actually better, and if I should stick to the old one or not. So because this video is just basically really an experiment to test which audio is actually better and more suitable for the videos and the audio quality. Right, so with that out of the way, let's actually dive into the problem statement. So we're given a string S containing just the characters of opening and closing parentheses, opening and closing curly brackets, and opening and closing regular or straight brackets, and we have to determine if the input string is valid. And we know if an input string is valid if it meets the following three criteria. Number one, open brackets must be closed by the same type of brackets. So basically, for example, an opening parenthesis can't be closed by a curly bracket. It has to be closed of a parenthesis of the same type, right? A closing parenthesis of that too, right? Which brings us to point 2 that says open brackets must be closed in the correct order. We can't have an opening bracket come first and then have we can't have a closing bracket rather come first and then an opening bracket, because that would be out of order, and that would be something like this if we had a closing bracket first, and then an opening bracket. This, of course, is not valid because we can't close a closing parenthesis with an opening parenthesis. It's actually the other way around, and so this would not be valid, and we'd output false. And every closed bracket has to have a corresponding open bracket of the same type, right? So that's also very important. Like I said before, we can't close an opening parenthesis with a closing curly bracket because, of course, they're not the same type of brackets, or parentheses in this case. So, like you guys may have noticed, of course, we are going to be basically outputting a Boolean value. So for any of you C++ users, this would just be bool and then main, or whatever you'd like to call it, right? And so on and so forth, right? So in example 1, we have an input string S of an opening parentheses, and then right after that, or adjacent to it, a closing parentheses. And since the opening parentheses is in the correct order and it is getting closed by its same type closing parentheses and on the brackets, this actually is a valid string, and so we'd output true. And applying that same logic to examples 2, 3, and 4, we'd output true, false, and true, respectively. Because for example 2, of course, every single bracket or parentheses being closed by the same type in the correct order. For example 3, of course it isn't, because we have a different data type or a different parenthesis type being closed by an open parenthesis. And then in example 4, it's completely fine, even though we have nested parentheses or nested brackets within a big parenthesis. Although they still are being closed by the same type, and it still is a valid input. So I will give you guys a few seconds to kind of just go over this problem in your head and think of a solution. And if you guys can't think of a solution, that's completely fine. I will tell you guys how I would optimally solve this problem in just a few seconds. Okay, so before we actually get into the main algorithm of this problem, let's actually talk about which data structure we should use. And if you guys haven't picked up yet, we would actually use a stack as the data structure, right? And a stack in this problem is particularly useful because it allows us to efficiently track and match opening and closing brackets in a last in, first out, or LIFO order. And the reason why, more detailed of why using a stack is effective, is because when we encounter an opening bracket, for example, an opening parenthesis or an opening curly bracket, we can push it onto the stack, and when we encounter a closing bracket, we can check the top of the stack. The last opening bracket should always match the current closing bracket, which aligns perfectly with the last in, first out nature of a stack, right? Basically, the last in opening bracket should match the first out closing bracket. And for matching pairs, basically by popping the top element from the stack when we actually encounter a closing bracket, we can easily check if the most recent opening bracket corresponds to the closing one. And if it does, we can continue, otherwise the string is not valid, and we can already immediately output false. And for unmatched brackets, if at any point we encounter a closing bracket and the stack is already empty, that means there's no matching opening bracket that's already in the stack, and so the string is invalid. And similarly, if there's still unmatched opening brackets left in the stack after processing or parsing through the entire string, the string, of course, is again still invalid. And for basically the approach of using a stack, we traverse through the string, and then for each character, we'd say if it's an opening bracket, we can push it onto the stack. If it's a closing bracket, it gets a little bit more complex. We'd have to check if the stack is empty. If it is, we'd return false because there's no matching opening bracket or corresponding opening bracket. And otherwise, we can pop the stack and check if the popped element is the corresponding opening bracket. And if it isn't, for any iteration I, we'd return false. And at the end, if the stack is empty, meaning all the brackets were properly matched, we'd return true because we'd popped for every single element in our string, right? Basically, every single element is valid, and if it's not empty, we can return false. So that's how this code really go. And so to initialize our stack, like I said, with the last in first out manner, it's really the same declaration of an array or list in Python. And I simply use the opening brackets or the regular brackets to actually initialize that to be an empty stack. Now, to actually monitor which corresponding bracket maps to its corresponding opening bracket, we actually have to use a hash map for that. And I could call this hash map in Python if I really wanted to, since that's not actually a keyword. But for the simplicity of this solution, to actually access it a lot easier, I'm just going to call it H, because we're going to be accessing this hash map quite a few times within our code base in this algorithm. So I'll set it equal to, of course, a hash map using this curly brackets. And I'm essentially going to map every single closing bracket with its corresponding opening bracket. And you guys will see how that actually is visually demonstrated in a few seconds, right? So for the curly brackets, I'll get the closing part to be mapped to its opening curly brackets, or its opening counterpart, and I'll apply that same logic to the straight brackets. Awesome. So now that I've really initialized my hash map and declared every single mapped opening bracket with its corresponding closed bracket, or sorry, the other way around, rather, now I can actually loop through our input string s. And so what I'm going to do is I'm going to say, for I in the input string s, I actually have to check, hey, is my current element that I'm looking at, is it actually, okay, I don't know why this isn't indenting correctly. Okay, so I didn't actually indent this right. Okay, so I'm just copy and paste that. Okay. Okay, yeah. Sorry guys, having some indentation errors here. Okay, so I'll say for I in the input string s, I actually have to check if I is in hash map. And if this is, what this essentially is saying is, if I is actually a closing bracket. And you may be a little bit confused for you non-Python users, because if I is an H, that should basically check for if I is a single element in H, which H contains both closing brackets and opening brackets. So Y would just only check for closing brackets. And this is the reason why. For a quick example here, and of course, if you are a Python user, you can just skip this part and move onward. But typically in Python, at least that's what I know, when we declare hash maps, we're going to be declaring it with the curly brackets, right? Set it equal to curly brackets. And essentially what we're going to do with this is, let's say, in this case, 5 is going to map to 2, 3 is going to map to 4, 2 is going to map to 4, and 6 is going to map to 7. When we want to check if a current element or iterator I is actually in the hash map, let's just say if I is in hash map, this simply checks if the key value is actually in the hash map, right? Not the key value pair, but rather the key value or the initial or first value in every single pair of the hash map's mapping, right? So when I check if I is in the hash map, I don't check if I is 2, 4, or 7. I don't actually check if it's actually a key, but rather if it's simply a mapping value or the initial value in every single pair, which in this case is going to be 5, 2, or 6. So if I is basically 5, 2, or 6, meaning it's in the hash map as a very first value of any pair in the hash map, great, it's true. And so I can simply just say return I, or whatever I'd like to do in this scenario. So in our case here, when we check if I is in the hash map, we're basically checking if I is one of the first elements, or the first elements in one of the pairs. And if it is, that basically means it's a closing bracket, because of course we map every single closing bracket as a key value to its corresponding key, which is the opening brackets. And so when I check if I is in H, it simply checks these first or initial values in every single pair, which in this case are all set or declared to be closing brackets. And once I've done that, if I actually say, oh, if I is in the hash map, great, I'm looking at a closing brackets. And I'm going to have another conditional, which is where the stack, or which is where the emptiness of the stack actually comes in. So if stack, or basically this is saying in Python, if stack is actually non-empty, and stack at the most recent element that we've added, or basically stack at -1, if that's actually equal to h at I, or it's basically its corresponding opening bracket, great, this is a valid element that we're actually trying to add to our stack, and so we can just say stack.pop, right? And keep popping off these valid elements, which we will ultimately return the not stack, or stack which is empty. Because if it's empty, every single element that we've checked is valid, and we've popped off all the valid elements within our input string s. And of course, if the stack is actually in the hash map, and this case doesn't set to be equal to true and we don't actually stack dot pop, then in that case we can immediately return false, because either our I is a closing bracket and either our stack is empty, or stack at -1 does not correspond to its corresponding opening bracket rather for this corresponding bracket, and so we could immediately return false for this iteration. And of course, if I is not even in the hash map, or basically if the current element that we're looking at in our input string is S, if it's not even a closing bracket, that's great, that's completely fine. That means it's an opening bracket, and since opening brackets are kind of independent, they don't actually depend on or rely on their corresponding closing brackets, we can just say stack dot append I. And I understand it may be a little bit confusing still of why we map every single closed bracket with its corresponding opening bracket and not the other way around. And so let me just kind of boil it down for you. When we process the string, we basically push opening brackets onto the stack and pop them off when we encounter a closing bracket. So this means that we only care about the matching closing brackets with their corresponding opening brackets at the time we actually encounter them. And the key idea here is that when we check the closing bracket after we encounter it, we basically have to use the stack to verify if the most recent opening bracket actually matches that value. And by mapping closing brackets to their respective opening brackets, we can check that the top of the stack, which contains the last opening bracket, and basically ensure that the most recent opening bracket is the correct one for the current closing bracket. And so essentially when we encounter a closing bracket like the closing parenthesis or a closing curly bracket, we immediately need to verify it whether it actually matches the most recent opening bracket, which is at the top of the stack, or basically stack at -1. And by mapping closing brackets to opening brackets in our hash map, we can directly compare if the top of the stack contains the corresponding opening bracket for the current closing bracket in this specific iteration. Right, so that's basically how this works. And once we've declared that it's not an H, or basically it's not a closing bracket, but rather an opening bracket, it's basically an independent case, and it doesn't rely on any closing brackets, and so we can add that to our stack as one more element that we've seen so far. Right, and then we can just move on to the next I element in our string S. Right, and ultimately once we're actually done adding and deleting from our stack or popping from our stack, we can simply return if our stack is empty, or basically if we've actually exhausted all the valid elements and we don't have any invalid elements. And to do this in Python, we can simply return not stack, or if the stack is empty, right? And so unless I made any syntax errors here, this should be completely fine, and this should be accepted. And as you can see, it's just about as efficient as you can get. And both runtime and memory complexity wise, this is actually going to be big O of n, where n is the length of our input string S, because we use an extra data structure of a stack, and of course we have a hash map, and of course we loop through the input string S just once with a bunch of conditionals just embedded within it. And so this is going to be O of n time, runtime wise and memory time wise. So if you guys enjoyed this video and understood the solution, please consider liking this content and subscribing to my channel. It really does mean a lot. And I actually forgot to cover this, but this problem is actually a very, very, very popular problem asked specifically in Nvidia as well, who, if you guys don't know, are actually booming in the market. Their GPUs are doing very well right now, and so, I mean, who wouldn't want to work at Nvidia, right? And Nvidia, sorry, not Nvidia. So if you guys enjoy this video, like I said before, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video.